So hello, I am Hayden Fennell. I'm this year's coordinator for the annual CompuCell3D virtual tissue modeling workshop. I know everybody has heard a lot from me via email the past couple of weeks, so it's good to meet some people virtually in person today. Just as a quick note, this session is being recorded and live streamed to the CompuCell YouTube channel. These live streams get turned into persistent videos for future viewing. So this session, as well as most of the workshop sessions, will be recorded and live streamed unless otherwise noted, just so everybody is aware of that. You can find today's slide deck if you'd like to reference it either during today's talk or later in the student materials folder, which is here. I will put the link in the chat. There will be a subdirectory called orientation, and inside of that there is a PowerPoint and PDF file with the slides for today. We do also have a Slack channel set up for this year's workshop. I'll go ahead and put that in the chat as well. We use the Slack channel often during the workshop for non-synchronous communication outside of workshop sessions for bug reports, helping people with their models they might be working on. And it's also a great resource for hackathon team building. So we do recommend that everybody sign up for the Slack workspace. There may not be a whole lot of activity on it until the workshop starts, but once the workshop starts, we'll be pretty active on there. For today, feel free to submit questions, concerns, or suggestions via the Zoom chat function. You can also just use the raise hand option and break in if you like, or just turn your camera on or whatever. We'll play it by ear today, no big deal. We'll talk a little bit further into the presentation about how to install CompuCell3D on your computer if you have not yet. If you have not, don't worry about it at this point. We can catch up maybe at the end of the session if people need help with that. And lastly, I would like to thank our funding sources through the NIH and the NSF. Their funding allows us to put on this workshop each year, so we are grateful for their help with this. So without further ado, welcome. This is the first official meeting of the 2025 CompuCell workshop. A few more things kind of happening in between now and the actual start of the workshop at the end of this month. But we will kick things off today by discussing what we're actually going to talk about. We're going to go over a little bit of kind of what virtual tissue modeling is and why do we need it. If you've signed up for this course, presumably you know a little bit about why we need it already. But if not, we'll be talking more about that today and during the workshop. We'll also go over briefly what CompuCell3D is capable of and some examples of previous work using CompuCell. And then we'll also take a little bit of time to go over things you might want or need to know to work with CompuCell3D effectively if you plan on using CompuCell3D in the future after the workshop. We'll provide some suggested resources for where to look for that information as well. And then we'll talk about how to install CompuCell3D, and then we will actually walk through getting a basic simulation running together. So if you have CompuCell installed already, once we get to that point, you can feel free to follow along with the example. If you don't have CompuCell installed, that's fine. The instructions are in this slide deck, or you can reference this video on YouTube later if you'd like to walk through it yourself. We'll also talk about where to go for help in between now and the workshop if you need it. A couple other things, we'll talk about course logistics, hackathon logistics as well for those who are interested in participating in the hackathon. And we'll talk about general resources for the class, where you'll need to go and bookmarks you might need to make, things like that. And then we'll have some time for questions at the end. Just as a side note, we do have more than 80 people registered this year. That number has actually gone up to 102 as of this weekend. So we will do our best to support each of you, but please do be patient. I generally have a 24-hour policy on emails. So if you have not heard from me on a question that you've asked me within 24 to 48 hours of sending it, please feel free to send me a reminder email. Don't feel like you're bugging me. Sometimes things, especially in the month leading up to the workshop, my email inbox gets very busy, and Outlook has a bad habit of trying to cluster similar emails together, even though I've told it not to. So sometimes things get put with other threads and may get missed. So please never hesitate to send me a reminder email if you haven't heard back from me within a day or two of sending an email. If you do have any experience with CompuCell3D, and you might be interested in helping to maybe TA some of the sessions or mentor a hackathon group if you're not planning on participating yourself, we'd love to hear from you. So if you're interested in helping in that capacity, or if you know someone who maybe has been using CompuCell and may be interested in helping in that capacity, please contact me at hfennell with 1L at iu.edu. So just a little bit of overview about virtual tissues. We're going to talk in more detail about what these are and how they model things during the actual workshop. So today is just kind of a very quick overview. But what we mean when we talk about virtual tissues is a mechanistic computer simulation of cell and tissue organization that we can use to observe emergent dynamics of various biological functions. These are basically just computer reproductions of cellular behavior, similar to the kind you might see imaged during experiment, with obviously some differences because this is happening in silico instead of in real world experiments. Virtual tissues come in a wide variety of scales. The scales range from sub-nanometer to meters, so a whole animal down to subcellular models can be found using virtual tissue approaches. Time scales as well range from seconds to decades in your simulations, just depending on what you're studying. CompuCell3D kind of specializes in what's in the dotted line here in terms of scale. So we're looking kind of at the organ, tissue, and multicellular level. So not necessarily whole animal, but some can do some whole organ depending on the number of cells required. We can definitely do tissue, which is, sections or chunks of organ, and then multicellular simulations as well, where you're just looking at what sort of individual cells are doing in a medium. CompuCell is also capable of some intercellular signaling with network modeling packages that can be loaded into CompuCell, and we'll talk about how to do that during the workshop. But the kind of spatial resolution of CompuCell, again, kind of ranges from the organ to the multicellular scale. Why use virtual tissues? So computation is becoming more and more important in basically all fields of study over the last few decades, but it's really starting to see a heavy rise in biology as well. One of the reasons for that is that it allows for the testing of situations that are impractical or sometimes even impossible to test in experiments. It reduces the need for animal experiments as well. If there's something that we can study with reasonable validity using a computational model, a lot of times it can reduce or completely eliminate the need to do an experiment on an animal in a laboratory, which obviously offers some ethical benefits. It allows us to visualize and communicate systems level outcomes and visualize time scale development of biological systems. It allows us to explore contrafactual conditions not possible in experiments, so we can set things up basically exactly how we'd like them to see how different outcomes come out. And it allows us to explore new conditions, like we said, that may not be possible to observe easily in experimental settings. So in complement with computational simulations via virtual tissues allows for kind of a filling in of the gaps that some of the limitations of experimental methods leave. So many other reasons for using virtual tissues. Like I said, we'll talk more about those during the actual workshop. But in terms of what we're actually going to be learning to model using CompuCell during the workshop, there's a number of different areas where CompuCell has been used in the past. It's been used to study development pretty heavily. So how does a fertilized egg organize into an adult? How do different types of tissues develop from undifferentiated cells and differentiated cells that take on specific shapes. Homeostasis, so how does an organism maintain itself? And then how does the failure of this homeostasis lead to pathologies in terms of developmental diseases? So how does the disruption of development create the conditions of disease? It's also been used to study infectious diseases. So how do the pathogens and the host interact? How do infections move between cells in a tissue? What determines susceptibility to those infections? Things along those lines. It's been used in a lot of toxicology applications, answering questions of why do certain compounds cause damage? What do they cause? Why do they cause the damage that they do? What determines susceptibility to different chemical concentrations? What do the prognosis and outcomes look like from early imbalances in chemical concentrations? You can kind of tie that together with developmental disorder. And this is all kind of building towards the key goal of providing information for medicine and bioengineering. So if we can understand the mechanisms behind a number of these phenomenon, we can try to develop methods for controlling them, repairing the damage, or creating new medications and treatments to kind of help take care of these issues. So just to walk through a few examples of what CompuCell has been used for in the past, just to show that it can be used for a wide variety of things. Again, we'll look at a couple of these examples more closely during the workshop. This is just kind of a quick lightning overview today. In the upper left, we have a simulation from 2016 on polycystic kidney disease that shows the development of cysts on the renal tubule segments in the kidney due to toxicological issues in the kidney. And you can see the A, B lines there showing the development of the cyst. This is a 3D simulation rendered in 2D to show the cyst on the plane there and the these kind of time lapse images. We have a tumor interacting with the vasculature network here. So the green ball in the middle is the tumor growing, and as it grows, you can see it interferes with the vasculature, breaks some of the connections where you've got the purple lines there. And in the process is also sapping nutrients from the vasculature network. Couple of simulations in retina research. So we have a study that was done with CompuCell on diabetic retina therapy optimization. So this is basically when you have damaged retina from diabetes using laser ablation, how do you, if you target different patterns with the laser ablation, how does it determine outcomes with the treatment? You can use that to optimize where treatment needs to go in specific cases. Simulation in the bottom right for retinal neovascularization. It's also another retina study. This neovascularization is a condition where the vascularization starts, or the vascular network starts to grow through the retina, back of the eye. You can see here the green cells represent the retina, red cells is the vasculature. And if you were watching the video a minute ago, you can see that after a certain amount of vascularization kind of intrudes on the retina, it can actually cause detachment, which you can see more clearly in the 2D view here. Skip ahead a little bit. And you can see it's about to detach from the substrate. And then once that's detached, it can actually cause retinal tearing. So again, understanding some of these mechanisms helps us better predict and treat these conditions in the long term. Some toxicological studies funded through the EPA. These are 3 studies that look at the effects of different initial chemical concentrations and how they affect blood vessel development. You can see here on the top, the blood vessels actually breaking apart and disintegrating due to toxicological imbalance. Another simulation and computational modeling of the genital tubercle development, and again, how chemical concentrations affect that growth. And then finally, a model on secondary palate fusion and disruption. So during development, the palate fuses together before the baby is born. And because of toxicological problems, sometimes that palate fusion is disrupted, resulting in what's known as cleft palate. So again, like before, understanding the kind of physical, spatial mechanisms here and chemical mechanisms behind what's causing these things is an important step forward in various treatments for them. Not going to get too deep into this one because it's a little bit complicated, but you can see that during the COVID era, CompuCell, although CompuCell's been used to study infection in the past, it definitely saw an increase during the COVID period. This is a study on viral infection and immune response in epithelial tissue, which you can read more about with the link here. We actually have an executable version of this on nanohub.org. If you want to follow this link later, there's a one-button simulation where you can just run it in your browser and take a look at how the simulation works. So long story short, CompuCell can be used to study a lot of different types of cellular-based phenomenon. We can most likely tailor the features of CompuCell to what you would like to model. Again, as long as it kind of sits within that scale limits that we talked about in the beginning. So by the end of this course, here's some learning objectives. You should be able to, one, look at a biological problem and ask quantitative questions that can be answered with simulations. So not all questions are actually answerable with computer simulations. And we'll talk during the workshop about how to approach that question of how do we actually break a problem down into something that can be meaningfully run within a computer. Then you'll learn to analyze the components of multicellular systems and their interactions and translate them into executable CC3D code. So you'll learn how to actually write CompuCell code to model the systems that you're interested in. And then you'll also learn how to basically work with your CompuCell simulation, learn how to display and analyze simulation data to derive biologically meaningful results. So once we have the simulation running, how do we first of all look at the output and determine if it's valid or not? And then once we've determined that it's valid, how do we make meaning of what we're looking at? How do we refine the model from there? So any questions about any of that before I move on to talking about course logistics? That's kind of the very quick lightning overview of what CompuCell is and what it does. Then next we'll talk about what the workshop is actually going to look like. So then let's talk quickly about course logistics, how the course is actually going to work so that you know what to expect for those 2 weeks. First of all, the Zoom link for the workshop and the Zoom link for the hackathon will likely be the same link that you used today to join the orientation. There's a chance we may need to make new links for those. If we do, we will be sure to send out the new ones, and you will receive a reminder of the link if we don't change it in advance of the workshop, and then the join link will be sent out each morning, and we'll do morning and evening announcements each day. So you should have plenty of references to the link all over the place in your email inbox, but we'll be sure to let you know if the link is changing. We have a link to our hackathon teaming document, which I'll put in the chat here. I know a couple people have just joined, so let me actually just repost the links as well. So I'm going to post the links to the student materials folder, the Slack channel, and the hackathon teaming document. We'll have more instructions on how to use this hackathon teaming document in a future email coming up in a week or two. There are some instructions on there already, so if you do want to take a look, if you're planning on participating in the hackathon, if you'd like to get started on maybe looking for team members already, feel free to put your project ideas in there, or feel free to put your information in if you're looking to join a group. Again, the workshop will be delivered completely via Zoom. I assume everybody in here has Zoom because you're using Zoom. So that's, I guess, fairly obvious, but Some Zoom logistics. This is an old slide from the early days of COVID when Zoom was still not as familiar to people, but I think at this point everybody pretty much knows how to use these softwares. Um, a couple of things to mention though here is that we will have for each session, there will be the instructor teaching the session. There will be typically myself as kind of the host running the actual meeting. And then there will be at least one TA in the room to help answer questions in the Zoom chat. Everybody's microphones will be muted by default just because we have a lot of people attending. And we do ask people to put their questions in the chat first, and then the TA or myself may see it. And if it's particularly relevant, we may interrupt the instructor and have them answer in real time. If it's something that is pressing, it looks like the subject's about to change, you can raise your hand and we can unmute your microphone so you can ask your question. So use the chat. Primarily, we have a lot of people in there that will help answer questions along the way. But if it's something that we feel the instructor should address directly, then we'll break in and relay the question to them. Other thing to note is to make sure that you have your Zoom client updated regularly. Zoom occasionally will put out, they're pretty consistent with their update schedule, but they'll occasionally put out kind of like midweek updates. And sometimes if the meeting host's client and the participant's clients is out of sync, it will disable things on the participant side, features that we use a lot like polls, sometimes breakout rooms, certain kinds of reactions, like the raise hand function, things like that. Sometimes will get disabled. Annotations and screen sharing as well. So you want to make sure that you get keep your Zoom client updated throughout the course of the workshop. We recommend when you sign in the morning before you join, just to quickly check for updates in the client. We do also recommend if you're using the browser version of Zoom, we highly recommend to actually download the Zoom client because there are some features in the browser version of Zoom that are not available as opposed to the full client. So things like polls are not available in the browser version. We do understand that there are sometimes internet limitations. Sometimes the browser version works a little bit better depending on your internet situation. So if the browser version is the only version you can feasibly use, that's fine. But if your internet can support a client connection, we recommend that you do that. Videos and PowerPoints and all demo code for each session will be made available for you to review if you miss any materials. So it's perfectly fine if something comes up and you have to miss a session or two throughout the week. We know that people are joining from all different time zones and people have family obligations and other things going on. So if you need to miss a session, that's perfectly fine. We will make sure that all the materials are available to you to catch up with later if you'd like to. You do not have to notify me if you're going to miss a session, but if you would like some help catching up, or if you need to be pointed towards the materials for that day, please do let me know and I'll make sure that you get the information that you need. Sessions will be converted into persistent YouTube videos at the end of each recording, live stream rather. Usually takes about half an hour to an hour for it to finish initial processing. So if it's not available right after a session, you maybe can just wait like an hour or so and come back and check and it should be available. And we'll send out links to each video from that day in the evening announcements each night. So just a quick overview of the people. So this workshop is largely put on by Professor James A. Glazier, who is also in the room today, and myself, both at Indiana University, Bloomington. And we have a core host of teachers with us this year, Professor Gilberto L. Thomas from Brazil, Pedro Sensi del Castel, also at IUB, Professor Giulio Bamonte from North Carolina State University, Jim Sluka and Lorenzo Vescini, also from IUB. They'll be doing teaching some courses on data wrangling and parameter scans and various more technical topics in the second week. Then we'll have Dr. Priya Madhyapuk from Duke University and Dr. TJ Sago from University of Florida. And we'll have some other people here and there, various guest presentations and things like that. But these are kind of our core teachers. So if you do need to get in touch with any of the instructors directly, their emails will be in the slides for each session each day. If you're not sure who to contact with a question, please feel free to email it to me. And if I can't answer it directly, I will put you in contact with someone who can. So our daily schedule for the course, if you have attended before or knew somebody who attended before, things are slightly different this year. We've scaled back to a 3-module session for each day, or a 3-module schedule rather. We used to do 4. We'll start at 10 a.m. each day, and this is again in Eastern Daylight Time, which is UTC -4 for those coming from different time zones. We'll start at 10 a.m. each day. We usually open the room at around 9:30, no later than 9:45. And we use that time for various discussion, troubleshooting, quick questions that you might have before the start of the day. So if you do have something that you'd really like to ask before we get started, you can join a little bit early. And me and James, and at least usually a couple of the other instructors will be there to help answer those questions. From 10 a.m. to 11:30, we have our first module of the day, and these modules consist of somewhere around 30 to 45 minutes of lecture, and then around 45 minutes of hands-on exercises kind of dispersed throughout the session for you to get some experience in actually working with CompuCell code. From 11:30 to 12, we have what we call our extra session. This is a half-hour session where we just talk about various different topics. Some of them will be used for hackathon preparation and lightning talks. Some of them are used to do quick presentations of work that's currently being done in CompuCell. Some of the sessions are used for additional Q&A or maybe talking about topics that don't fit easily into one of the other longer modules. So we'll have a schedule of what we have planned for those extra sessions sent out before the beginning of the workshop. From 12 to 1, we'll have an hour-long lunch break, and then we come back at 1 p.m. for Module 2, followed by a 30-minute break from 2:30 to 3. And then from 3 to 4:30, we'll have our final module of the day, Module 3, before leaving half an hour for Q&A and discussion with the questions and instructors for that day. So the instructors from each session that day will come back at 4:30 and be available to help answer questions. We usually go a little bit longer than 30 minutes if people have something more complicated they'd like to talk about, or if you're having an issue that you need help troubleshooting. That 5 p.m. cutoff is kind of a loose cutoff. We usually stick around anywhere from 45 minutes to an hour after the sessions each day. So we'll be finishing at 5 p.m. each day, starting at 10 a.m. Eastern Daylight Time. So the next section, we're going to talk a little bit about some background knowledge and reading that you may want to spend a little bit of time on before the workshop. Don't let this portion of the orientation freak you out too much. It's going to seem like a lot. The reason why we bring this up is not because we feel that you must know all of these things, but we think that it is useful for you to see kind of all of what's actually involved in doing modeling, maybe more professionally, to give you kind of a feel for where you may want to fill in some gaps if you want to spend time in advance of the workshop brushing up on some different topics. We will teach you everything you need to know during the workshop to use CompuCell and build basic models and follow along with all of the examples. So again, don't feel like you have to do any kind of in-depth reading before the workshop, but we have found that it helps people to spend a little bit of time just familiarizing themselves with the field, at least getting familiar with the terminology, which helps kind of lighten the load during the workshop because we will move a little bit quickly through some of the content. So we think of biological modeling as consisting kind of 5 big pieces, at least biological modeling within CompuCell. You've got the principles of modeling in general, so how to abstract a problem into something that can be modeled, and then how to actually model it in a way that is meaningful and valid. You'll need to know a little bit about Python programming. CompuCell uses a combination of XML, and Python. So if you don't know any Python yet, that's okay. We have tools for you to learn, but you will need to work with Python a little bit when building your CompuCell simulations. Obviously, if you're doing biological modeling, you need a fairly reasonable understanding of the biological principles that you're trying to model. Um, we have people from all different kinds of backgrounds doing this kind of work right now. Some people from physics, some people from mathematics. Myself, I'm from materials science. So people come from all over to do this kind of stuff. But obviously, you do need to pick up some of the biology along the way, particularly if you have a system that you are looking into modeling um, more long term for larger projects. You need to know a little bit about biophysics and a little bit about mathematics as well. So again, you don't need to be an expert by any means in any of these topics to do modeling with CompuCell, but it is helpful to know a little bit about all of them. And we'll go over maybe what might be good to know in the following slides. So the purpose of these slides, again, is just to give you a list of things to kind of be thinking about until the workshop hits. And the idea here is that if none of the bullet points sound familiar to you while you're reading through some of this stuff, it might be worth spending a little bit of time doing some reading using the resources that we'll share in a few slides here. So for background principles of modeling, we have some basic things like being able to define questions that can be answered by models, understanding where and when models are useful and appropriate, when and where they're not, um, being able to select meaningful variables and parameters for your model. So learning how to kind of look through the literature and find good starting points for your models, and being able to determine whether or not those are giving you the outputs that you were anticipating. Deciding which components and mechanisms are important. So it's actually very rare that you would sit down and build a computational model that is an exact one-to-one replica of the physical system. Um, Usually that's too computationally expensive, and it's also usually not necessary to answer the questions that you're trying to answer about your system. So being able to determine which pieces of the very complicated real-world biological system can be safely removed to still answer your questions is kind of a big part of the modeling process. And then things like understanding the limitations of models and some basic processes for model validation and falsification. So understanding, first of all, is the model producing output correctly, and is the output it's producing in line with what we would expect to see in the actual biological system. So next, some basic things on Python programming. This is kind of the piece that you might need to do the most prep on if you haven't ever done Python programming before. And we do offer our one-day Python bootcamp for people who have never programmed in Python before or who would just like a refresher in Python. Python is a very well-established language at this point. There's a lot of resources for learning Python, but it's so popular that sometimes it's kind of a double-edged sword because there's so many resources, it can be hard to find useful materials that aren't overwhelming. So the purpose of our one-day Python bootcamp is to teach you basically from zero everything you need to know about Python to use CompuCell and nothing else. So if you're not familiar with Python, we highly recommend that you attend the Python bootcamp. If you're not able to attend it in person because of when it's being held or scheduling issues like anything like that, the Python bootcamp videos will be available on YouTube the day after our Python session, and we will make sure that everybody has the links, and you'll have about a week to review those before the workshop starts this year. So some basic things to know. Again, if you're looking at this list and none of this sounds familiar, then we definitely recommend doing our boot camp with things like basic syntax and indentation, understanding the structure of loops and how they're controlled by Boolean logic and conditionals, object types. There is a little bit of inheritance going on in CompuCell simulations, not a lot, but enough that it's important to know what inheritance is. Things like the self.dot class, what a class even is, how to write attributes and methods for custom simulations, and then dictionaries are also kind of an important part of CompuCell that are common in Python, but don't actually seem to get talked about a lot in training materials. So we'll go over dictionaries and how to use them in CompuCell in our bootcamp day. So in terms of background for biology, obviously, if you're modeling cells, it's important to understand what cells are and what they do. Things like how do cells generate forces. Here on the right, we have a cell walking cartoon diagram of a cell um, using various mechanisms to move along the substrate. One thing that this ties into is this bottom point about how biologists represent information. So these cartoon diagrams often have a lot of sort of standardized pieces to them. And after you've looked at a number of them, you start to kind of get familiar with the various types of icons and ways that information is represented. So looking at some of these cartoon diagrams can be helpful as well. Various other questions. How are tissues constructed? How do cells stick together, basically? What is cell polarity? What is planar cell polarity? How do they differ? We'll actually have a session talking about some of the elements of that in week 2 from Giulio Bamonte. What's the extracellular matrix? How do cells communicate? What are the basic motifs of biological networks? So again, the point here is if all of these are looking unfamiliar, then it may be worth spending a little bit of time either looking at the resources that we have to share here or potentially just kind of browsing Wikipedia entries for these various topics. In terms of the biophysics piece, so the biophysics stuff can get pretty complicated pretty quickly, especially on Wikipedia, if that's how you choose to learn. But the big piece here that we usually tell people is probably the most important to have a little bit of background on is diffusion. So we'll have a day or a module on day 3 or 4 of the workshop, I believe, on chemical diffusion gradients and how that works in CompuCell. But understanding the underlying mathematical models can often be very helpful for, first of all, understanding if your simulation is working properly, and also for debugging if your solvers are not working the way that you expect. You can also look into the basics of the cellular pots and GGH model if you're interested. We'll have an introduction to that in day 1 of the workshop. But this is the underlying algorithm that runs CompuCell3D. So if you're interested in learning more about that in advance of the workshop, we actually have a couple of resources coming up here. Also understanding what are constraints, how are constraints picked, how do they correspond to the real world phenomenon, how do they combine and interact. Again, just a couple of important topics here. And for the mathematical component, what we'll probably say here for now is that the most important thing to have an understanding of for using CompuCell is understanding a little bit about first order ordinary differential equations and rate laws. We won't be talking a whole lot during the workshop about the mathematical side of things, mainly because it's with the examples that we'll be doing, we won't be getting super mathy. But again, it is always helpful to kind of understand what underlies these systems. We have some figures on the right here. These are from dynamical systems theory about stability and fixed points bifurcations, kind of looking at the outcome space of various parameter sweeps in the model. Yes, so I think that that's all we'll mention here. Again, don't worry too much if you're not an expert in any of these topics. These are just areas where we think it might be useful to do a little bit of reading if you have the time before the workshop. Here are some places to do that reading. So I'm not going to dump all these links into the chat today, but again, you can find the orientation slides in the student materials folder, which I'll drop in the chat again, just to make sure everybody has it. We have some resources for reading up on principles of modeling. This is a paper for 10 simple rules for building your mathematical model, kind of targeted at beginners. And we have the first module of another project that we're working on with a group at Purdue called the Embryo Institute. We're working on developing an online textbook that covers a lot of this material. So if you'd like to learn more about our workflow for developing mechanism-based computational biology models. You can visit the first module of our ebook over there. For learning Python, the official Python tutorial is pretty good these days. I believe you only need to work through the first 4 or 5 modules. There's a lot more than that, but after those first couple, it kind of gets into very specific stuff that we won't be needing for CompuCell. So the first few modules of the official Python tutorial are a great starting point if you've never used Python before. We also like to recommend people this set of exercises from Rosalind called the Python Village. It's a 6-exercise mini course with actually grades your submissions and tells you if you've done them correctly or not. So it's kind of a good way to do a little bit of self-assessment on your Python knowledge to determine if you need to come to the bootcamp or not. If you can do exercises 1 through 5 on the Python Village, you're in pretty good shape. And again, if you can't do the exercises, that's fine. We will teach you what you need to know. I have some more resources here on network modeling if you'd like to read up on that before we talk about it on Friday of week 1. And then a couple more recommendations here for textbooks to refer to for the mathematics, biology, and physics component if you're not finding what you need on Wikipedia entries. We often recommend if you find that the latest version of these textbooks is too expensive, that if you just drop down an edition or 2, prices usually are severely diminished down to like $15 or $20. And obviously the core information about the math and the biology and the physics hasn't changed much over the last few editions. So you can always order an out-of-date edition of the book for much cheaper typically. And if you're interested in learning more about the cellular POTS model, you can go back and read the original CompuCell paper from 1992 that introduced the software. It's always interesting to see how far it's come since then. If you find any resources along the way that you think are very useful or very helpful to you, please do send them my way and we can take a look at them and consider adding them to our official list of recommended materials. We're always happy to put it in the student materials folder for other people to access as well. Assuming that we're not violating any copyright, obviously, but work on that in a case-by-case basis. All right, so in that case, we'll move on to discussing course resources, where to find information about the course. So the best place to find up-to-date information about the workshop is through the website, which is just CompuCell3D.org, and we have a sub-page for the workshop, which is CompuCell3D.org/workshop25. We will be updating that fairly frequently leading up to the workshop with new information about dates for pre-workshop sessions, updates to the schedule, anything important that you may need to know about that. And we will also be sending it in a weekly Friday newsletter, basically, to everybody who's enrolled. So keep an eye on your email inbox. If you lose any of the information, just check the website. It should all be up there. If you do notice that something is out of date or incongruent with something that we've said in an email, please don't hesitate to let me know so we can get that fixed if need be and clarify dates. You can download CompuCell at our source bin page here. You can also find online help in the manual for CompuCell through our website. We also have a CompuCell3D Quick Start Guide, which is a good way to learn how to build a few basic simulations once you've gotten CompuCell installed. We are working on updating that Quick Start Guide right now, but currently it's based on CompuCell 3.6. We're currently in 4.6. So the Quick Start Guide is a little bit outdated, but most of the core information is still the same. There may just be some differences in interface. You should still be able to build all of the examples in that Quick Start Guide. Again, class files can be found in the student materials folder in our course Google Drive. If you haven't signed up for the Slack yet, please do so at your convenience. And then we also have some links here to our quick reference guides pages, which we'll talk about in a minute. So again, the Slack channel is useful for talking to your workshop mates. We will have instructors checking in on that periodically to see if we can help with any issues that come up along the way. But its main purpose is to allow you guys a place or a space to talk outside of the workshop sessions. It's also very useful for organizing hackathon groups and for sharing files with your team and with other teams during the hackathon. We'll have different channels set up for different topics. So please feel free to use the Slack workspace however you see fit during the workshop. The Slack will be available in a permanent-ish setting for up to 60 days after the workshop. After that period, we start to lose some features, but you should be able to access the information and download shared files for up to a couple of months after the workshop. So you may want to make sure that you grab whatever you need from the Slack kind of soon after the end of the workshop to make sure that you don't lose access to any of that. I have a couple of quick reference guides, one for Python, basic commands you might need to know, and these are in the following folder, which I will put in the chat. And that's, again, this is a subdirectory in the student materials folder, so you can find everything from the student materials folder. I just posted the direct link there. We recommend downloading these to your desktop or somewhere convenient where you can open them when you need them, or even better, printing them out and having them on hand, especially if you're not as familiar with Python or the various CompuCell properties and commands. They can become in very handy to have them kind of ready to look at when you need them. We have some extra readings available in the course drive, which are in the following folder, which I'm dropping in the chat again here. So if you're interested in doing some reading, some various studies of CompuCell's history and some different projects that have used CompuCell, if you want to get a look at what kind of official published work using CompuCell looks like, we have some sample papers in this folder if you'd like to get or like to spend a little bit of time skimming through those before the workshop. Okay, so information about the hackathon, and then we'll have a quick walkthrough example of how to build a simulation in CompuCell. That should take about 15 to 20 minutes, so we should be wrapping up here at about 4:20 for anybody who maybe is on a time crunch, just to give you an estimate. Hackathon details. Our hackathon this year will be from Friday, August 8th to Sunday, August 10th. The first day on Friday will be mostly time spent helping people finalize their project groups and get started on putting together the initial stages of their project. And then they'll have Saturday and Sunday to do actual work on the project. We will be hosting at least one hackathon project pitch meeting in advance of the workshop. We're still trying to finalize the date and time for that, but we will make sure to let you know as soon as we have it nailed down. The idea here is that people who have an idea for the hackathon come to give a lightning talk of roughly 3 to 5 minutes, where you can pitch your idea to other interested hackathon attendees. We have a template for a presentation to talk about the problem you want to model. And this gives people kind of an idea of what people are interested in doing for the hackathon. So if you have a hackathon idea, but you feel that it's maybe too big for a 3-day event, or if you aren't sure what can and can't be done in CompuCell yet with regard to your project, we can certainly help you kind of scope your project into something that we feel is achievable during the hackathon. The goal isn't necessarily to have a complete, validated final model by the end of the hackathon, but generally people do end up with some kind of working prototype that they can then move forward with after the hackathon if they're interested. So we like to make sure that everybody comes in with sort of a realistic goal so that you can leave with a functioning prototype that you can then iterate on after the hackathon. So we are available to help with that. We are also available to help with organizing teams. Generally, hackathon teams are self-assembling and self-organizing. But if you have a project and you're having trouble finding people to help you with it, or if you're interested in just joining a group, but you're not sure which group you might be the best fit for, we are happy to help place you one way or the other. So we can make suggestions in that regard because we'll have a good idea of what everybody is doing as we approach the hackathon. As far as hackathon structure, the days will be roughly the same as the workshop days. So we'll go from 10 a.m. to 5 or 6 p.m. And that will be mostly just work time where you are working in a breakout room with your group, and we'll have instructors circulating to help answer questions and guide the process and debug things, stuff like that. We'll have check-ins in the morning and at noon with the whole group. So everybody will come back to the main room and we'll just have you do a very quick check-in of how things are going. You can tell us where the project currently is, if anything unexpected has happened, and what kind of help you need from us so we can make sure to target our assistance as appropriately as possible. And then each day we'll have a brief evening report so that we can have feedback ready for you the next morning. And that's just kind of again, just showing us where the model is. On Sunday, we have time set aside for short oral presentations and model documentation. So each group will kind of show the end result of what they got by the end of the hackathon. And again, these projects are all different scales, all different levels of functionality. But in general, everybody does leave with a working prototype. So we just like for everybody in the room to see what the other groups were able to do with their hackathon time. And then we do offer post-hackathon support with the CompuCell team, or if you need help getting connected with somebody maybe from a different group in the hackathon, we can always help with that too. But we're available to help if you'd like to continue working on your model or a different model, either to turn it into a potential publication, a thesis project, or if you're just interested in pursuing it as an individual learning activity, that's perfectly fine as well. We are happy to help with any of that after the hackathon. If you're interested in participating in the hackathon and you're thinking maybe I'd like to lead a project group, but you don't know exactly what you want to do yet, we always recommend reproducing an existing model using CompuCell. If you don't have a specific idea in mind, we have a list of suggested papers that we think are good candidates for turning into a CompuCell model. Reproducing an existing model is a good way to get some modeling experience and lightening the load of a lot of that kind of conceptual heavy lifting at the beginning of the process by jumping off from kind of an already established problem. So again, we'll have a hackathon channel in the Slack workspace. And I shared that Google Doc earlier. Let me go ahead and drop that in again here. Again, we'll send instructions on how exactly to use this document in this week's update email. But I think there are instructions in there already. It should be relatively straightforward if you'd like to go ahead and put your project idea in there. And then we have a list of possible reproduction papers in the Google Drive. It's in student materials in the subdirectory hackathon. I don't have this link on hand, unfortunately. I can grab it later if anybody needs it. But it should be relatively easy to find. As far as expectations for the hackathon go, we have a couple. If you like to lead a project group, we obviously would like you to have some idea of what you want to model and why. So being able to share the motivation of why you want to model it with people is a good way to pitch your project. If you're not wanting to run a project group, but you do want to participate, having a shareable description of yourself and your skill set or background is very useful. Again, it's okay if you're a beginner or if you don't have any heavy programming experience, that's perfectly fine. People contribute in a lot of different ways to these hackathon groups. Having somebody available to help with biological questions, with mathematical questions, um, even just with the modeling process. These things are all very helpful. You don't have to necessarily be a hardcore programmer to participate in our hackathon. So don't let that dissuade you. So again, it's okay if you're a beginner, but it is useful to have just a couple of quick notes about your background, kind of where you come from, what you've done that you feel might be relevant to a hackathon like this. Something that you can share with people so they can determine maybe if you'd be a good fit for the group. Um, Expectations you can have of us is that for those 3 days, we will be as available as possible for the entire time. Now, obviously, we can't necessarily be available 24/7. We all do have to sleep at some point. But for the most part, we will be available to help answer questions and assist with model building throughout and then after the hackathon. Typically, the way that the hackathon works is we will open the room at 10, and then we just leave the Zoom room open throughout the night because we know people working in different time zones might have to keep weird hours to make progress on their model. Typically, I check in periodically to see how people are doing, but you can use that Zoom space if you'd like, kind of throughout the evening. One final note, if you do intend to participate in a hackathon and you would like to do so as um, in a sort of programmer role, we do think you should be able to complete those Rosalind exercises 1 through 5. Again, that's more of a self-assessment. If you can complete those exercises, you're probably in good shape to help be a programmer in your hackathon group. And then we're going to spend the next 15 or 20 minutes kind of looking at how to actually build a basic simulation in CompuCell. So if you'd like to tinker around with it before the workshop, this is a good introduction. So with that, we'll move on to our CompuCell tutorial. Okay, so most people have it running, it sounds like. If you don't have it installed yet, again, that's perfectly fine. You can just kind of follow along or listen along today. And these tutorial steps are in the slides if you'd like to try it again on your own later. So if you do have any issues installing or running CompuCell, especially if you're on Linux or Mac, we strongly urge you to contact us as soon as possible. This applies both to if you can't install it or if you suddenly have issues with the stability of your installation or something like that. Please let us know right away so we can maybe schedule an appointment to meet with you and get those issues troubleshooted. We are working with only local installations this year during the workshop. We don't have a browser-based version of CompuCell currently. And we cannot guarantee that we'll have time for troubleshooting issues during the workshop, particularly during the sessions. The instructors don't really have time, excuse me, don't really have time to help with debugging your actual installation. Sometimes we can help at lunch and at the end of the day if something comes up during the day. But we would like to help people get their installations working before the workshop starts, if at all possible. It sounds like most people in here have already downloaded it. But the way you would do that, current version is 4.6.0, although sometime over the next couple of weeks, you may see that change to 4.7.0. We have a new release candidate that's currently being tested. So that may go live before the workshop. But currently, the current stable version is 4.6.0. And you can find that by going to CompuCell3D.org/sourcebin, clicking on the most recent release for your operating system, downloading the installer package, and then following the instructions there on the website. We won't get too deep into that today because it sounds like pretty much everybody has it installed. We will be having an installation session this Wednesday at 3 p.m., I believe. I'll be sending out an announcement about that later today. Couple things to note is that on the latest releases of Windows and Macs, your security firewall will try to tell you that CompuCell is not trusted. That just means that we haven't officially gotten a Microsoft certificate for CompuCell. That process is actually pretty involved. So you'll have to click, more info and then allow the installer or run it as an administrator to get through that increasingly pervasive security pop-up. And then to launch CompuCell, once it's installed, you just search for it on your computer, either in the Start menu or using, I think it's Finder in Mac. I apologize, I don't use Mac, so I'm not as familiar with the terminology. Um, when you do, it will open Player, which is one of kind of two pieces of software that come with your installation. The CompuCell3D Player is the tool for actually running, visualizing, and interacting with your CompuCell simulation. So this is where your output is displayed. And then Twedit is a built-in code editor where you'll actually be writing the code and interacting with the code, and then sending that to Player to run the actual simulation. So there's two pieces to CompuCell. And with that in mind, we will now walk through an example of building a cell growth simulation in CompuCell. So I'm going to reshare my whole screen. Let me make sure, yep, toolbar is showing now. And then I'm going to launch CompuCell on my computer. If this is the first time you're launching CompuCell, if you're unfamiliar with terminals in Windows, it's going to throw up this terminal window that starts outputting a bunch of commands, and it sort of looks like the stereotypical representation of a hacker installing a virus on your computer in a movie. We promise it's not. This is just the terminal output of the actual CompuCell package. This terminal has to stay open while you're using CompuCell. If you close the terminal, it'll close CompuCell. So do keep that in mind. You can just minimize this. But information about your simulation is output to this terminal, and sometimes bug reports get sent to this terminal. So if your simulation isn't working or if something is crashing, you can always check this terminal to see if you've gotten any kind of useful reporting out of it. So when CompuCell first starts, you'll start with Player. And right now there's nothing in our Player. I do have a simulation loaded, but that's from earlier today. So you can actually just, if you go to File, Open Simulation File, and Player, in your CompuCell3D folder, there should be a folder called Demos. You can just open that, and then there's a bunch of built-in demos to kind of demonstrate various CompuCell features in this folder. So if we go to Book Chapters, Angiogenesis, to open a simulation file, you just click once on the angiogenesis.cc3d file, and then click Open. Before we do that, if you go into the simulation, you'll see the actual Python files and the XML file. This is a pure Python, so it doesn't have XML, but you'll see the actual simulation files. But CompuCell needs to open this CC3D file, which is basically just a pointer to the simulation files. So we'll click Open there. And then you'll notice up here at the top in the title bar, our simulation path has changed to angiogenesis.cc3d, which shows us that it did load, but it isn't running yet. So in order to run it, we would hit play up here. Sometimes the player window will resize when you run. And then here you'll see our model of vasculatory angiogenesis. So this is blood vessels forming from an initial clump of cells. In 3D. If you're following along, you may have ended up with something like this. Instead of the 3D view, this is the XY, a slice along the origin of the XY plane of the 3D simulation. You can just change that by dropping this graphics drop down and changing to 3D. When you change visualization methods, it does pause the simulation. So you have to come up to your player controls here and hit play again to run it. and that'll just resume from where it was stopped. If you'd like to pause on your own at any point, you just click pause, and then you can either resume it with play or you can step it one step at a time with the step button. So if we click on this a few times, you'll see it's just moving step by step if you need to see kind of the stepwise development of something in your simulation. This is also an important debugging tool to determine when something is crashing. If you press stop, it'll look like it's remained paused, but it's actually terminated the simulation in the background. So if we go back to our terminal, you can see that it's putting out a performance report because we've actually stopped the simulation. And now when we run it again, it'll start over from the beginning. All right, so that's how to open and view simulations in Player if you just want to look at something in CompuCell without actually like looking deep into the code. That's how you would do that. I'm going to stop here. But now we actually want to make our own simulation. So what we need to do now is open Twedit because we need to actually write some CompuCell code. There's a couple ways to do that from Player. One is the Start Twedit button that looks like paper and a pencil. I know on modern monitor resolutions that can be very small, but it's here next to the Open Simulation and Configuration. If you can't find it in your toolbar here, you can just go to File, Start Twedit. You can also open Twedit directly from your Start menu if you search for Twedit instead of searching for CompuCell. And then it will just open Twedit and not CompuCell Player. Sorry, I just realized my camera was out of focus. Hopefully it wasn't like that for too long. That can be very distracting. All right, so here on the left, we've got Twedit open, our editor. And on the right, we've got Player. And what we want to do here is make a new simulation. So we're going to go to CompuCell3D project, new CompuCell3D project, and then you'll be given the simulation wizard. The simulation wizard is basically a series of questions and prompts that will collect some information about how you want to initially set your model up. And then once you complete the wizard, it will generate the necessary CompuCell code as a starting point. You'll need to make changes to your code typically to add more complexity to your simulations, but this is a way to generate initial code so that you don't actually have to sit down and write everything out by scratch or by hand every time. So first things first is we want to select a simulation directory, and you want to make sure that you pick a directory that, first of all, you have full read-write access to. Somewhere in your user profile where you have full permissions to read, write, and make edits. And you want to make sure that this is not pointing to a cloud directory. So for example, in the latest versions of Windows, if you just did a default installation where you logged in with your Outlook account at the beginning of setup, sometimes that means that the documents, pictures, music, downloads folders on your computer are actually your OneDrive folders. So you want to make sure that you're not saving it in a cloud directory because those cloud directories will try to like auto sync things, and that can cause a lot of problems along the way. CompuCell is not like that. So somewhere in your user account on your computer where you have full read-write access. In my case, it'll just be my user account and then the desktop and then this folder I've made for these demos. Then you want to give your simulation a name. A couple things to know about naming CompuCell simulations. They must start with a letter of the alphabet. They cannot start with a number or a special character. So I could not call my simulation 2Cells. It has to start with a letter. So I'm going to call it growth simulation. And then I need to give it a number because it's the second one I've done today. You cannot include spaces, hyphens, or periods in your simulation name either. That causes issues with the simulation's parsers thinking that a file name ends too soon and it can cause the program to crash. So instead of spaces, we use underscores. So basically the rules are it has to start with a letter, and it can't include hyphens, periods, or spaces. There are some other special characters that cause issues, but that's less common. So we recommend just alphanumeric characters and underscores, not starting with a number. So if you're following along, we're going to leave this Python plus XML checked because we do want both file types. And then we'll click Next. So it is worth noting as well, nothing is saved yet until the wizard is finished. Then it will create the simulation files and save them to your computer. So issues with read-write access on your computer may not be obvious until you actually go to finish the wizard and run the simulation. Just something to keep in mind. So our first page of our wizard is our general simulation properties. This is where we specify the initial conditions of our simulation setup. So we want to make a two-dimensional lattice, in this case, of 256 pixels in the X and Y dimension, and then 1 pixel in the Z dimension. So even though the software is called CompuCell3D, we often do models in 2D for initial testing, or sometimes 2 dimensions is all we really need to observe our phenomenon. Boundary conditions on each axis, we're going to leave as no flux, but you can choose between no flux and periodic. Lattice type is square. CompuCell can run both square and hexagonal lattices. We're going to leave it as square for now and for most of our simulations during the workshop. Average membrane fluctuations. This is basically the intensity of fluctuation in our simulation. It's called temperature sometimes in the code. Pixel copy range, how far each pixel can see, and then number of Monte Carlo steps. And then we're going to create our initial cells in a rectangular slab, and we'll leave the units alone. If you're running CompuCell 4.6, these units are not included in the wizard yet. That's a feature on the upcoming 4.7 update. So we'll click Next. And then we have cell type specification. So you'll notice here it starts with medium. All simulations must have medium in them, and they will be included by default. This is what the cells sit in, move around in. And we want 2 cell types in our simulation. So we're going to call the first one cell 1, then our cell type bar, and then we'll click Add. And then we want cell 2, and you can also add just by pressing Enter. And once it's been successfully added to the simulation, you'll see it populate up here in the table. And these can be called anything. These are just tags for the code. You can call them green and blue and then change the colors accordingly or anything like that. So it's up to you. So we have our 2 cell types and medium. We'll click Next. Here we select our cell properties and behaviors. We want for our simulation. So again, all the steps are in here in these slides. I'm just walking through for you. Let's catch the slides up. So for our simulation, we want our cells to have variable volume. We want them to grow, and we want them to stick to each other. We want them to grow and divide. So we need to select from our wizard the contact plugin, the growth plugin, the mitosis plugin, and the volume local flex plugin. And what this is doing is when you select these, when you create the simulation, it will insert those plugins in the appropriate code file for you, so that you don't have to add them in yourself. So if we go back to our wizard, we'll click Contact because we need the cells to stick together. We'll click Growth because we want them to grow. And you'll notice over here that our options and some of the constraints and forces narrowed down when I clicked on that. Growth is only compatible with volume local flex and surface local flex. So that's why you may see those changes over there. We'll click mitosis as well because we want the cells to divide, and then we'll click our volume local flex, which allows our cells to grow. or sorry, it maintains a consistent volume at each step. The growth is handled, believe it or not, by the growth plugin. So once we have all those clicked, we'll click next. You'll be asked about chemical fields. We are not including any chemical fields in this simulation, so we're going to leave that blank. And by not doing anything here, it will just leave that plugin out of our simulation. Then you'll be greeted with a configuration complete window. The simulation will be generated now, which means it is actually not done. You have to click finish, and then it will create the files and save it to the location you specified. So we'll click finish. And then you should see in your TWEDIT project window, we now have a simulation project up here. So if we double click on that, it will put our simulation files in our file browser here. And you'll notice that this consists of 3 files. We have an XML file. This is the simulation specification file. So this tells the simulation how to set everything up at the start of the simulation. And you'll notice here, these correspond to some of our wizard prompts. So here we have our dimensions that we put in, 256 by 256, 100,000 Monte Carlo steps, our membrane fluctuation amplitude of 10, or our temperature, neighbor order of 1. We have our cell type plugins here, tracking our cell types. Our volume plugin, which is actually handled by the Python file, but it's specified here. And then our contact plugin, uniform rectangular slab initializer. So you see that the things that we were specifying in the wizard have just been translated into initial simulation code. You'll have a Python file named after your simulation. You'll almost never have to change anything in here. This is just telling the system to start and run the Python script that runs the file. Where you may need to make changes, though, is in the steppables file. So this is a Python file that tracks what we call steppables, which are plugins that make changes to those initial values in each step of the simulation. So you'll see here we have volume constraint. We have our growth steppable, which changes the target volume of each cell during each step. It adds 1, so the cell grows. We have our mitosis steppable, so this is cell division. This basically does this by saying if cell volume is above a certain value, we tell the cell to split into 2. And it inherits from the parent. So now we have 2 cells where there used to just be 1. So that's a quick overview of what the code looks like. And now to run it in Player, we would right-click on our simulation in our project window and then click Open in Player. So I'm going to do that now. This crashed on me earlier today. Yeah, looks like it's doing the same thing now. Give me just 1 second. I'm going to reopen CompuCell. Like I said, I have the 4.7 version of CompuCell installed, and it may be conflicting with having another simulation loaded. So I'm going to start TWEDIT again. I'm going to open my growth simulation project and then open in Player. There we go. Now it's working. So you can see on the right here, we started with a rectangular blob of cells, and they are growing, pushing each other outward. And if you focus on a particular region of cells, you can see that once they reach a certain size, they split into 2 cells and begin growing again. And this is, again, a 2D simulation, which is basically just running 1 layer of cells. If you switch to the 3D view like we did before and play it again, well, maybe not. Should be seeing a grid. Troubleshoot that later. But you can see the cells growing and dividing. Up here we have our model editor, which allows you to make changes on the fly to the cells in our running simulation. So for example, if we wanted to drop down our POTS plugin, we have our temperature there that we talked about before, our fluctuation amplitude. If we increase that to 50, you'll see the cells get a lot more chaotic. They're reaching out further with each step to try to move around. So you can see the borders of the cells become more frazzled and less cohesive. Drop this back down to 10, you'll see them return to more stable borders. And then, for example, if we wanted to change our contact energies, so if we wanted our cells to have differential adhesive sorting, which we'll talk about in day 1 of the workshop, we could find our energy value that corresponds to cell 1 and cell 2, and if we make that high or higher, they won't want to touch. They'll want to touch cells of the same type. So let's change that to 20, and you'll actually see you get these kind of cohesive groups of cells forming while they're growing and dividing. We can make the effect even stronger if we increase it to 25. And then if we drop it back down to 10, so the same as all the others, you'll see that the cells kind of remix. So that is the end of our demonstration for today. I'm going to go ahead and click stop there. I've got one last slide to look at. Then we'll have a little bit of time for questions. Again, the slides include, we have a deeper look at the simulation specifications here. If you'd like to do a little bit of extra reading about what each of those plugins does, we have a walkthrough of this example that kind of shows you exactly what each portion of the code is doing. So you can take a look at that on your own later if you'd like to get a better feel for how this example actually works. And then the last thing for today is basic preparations. So things to do to prepare for the course. Make sure you can launch CompuCell on your local computer and that it runs stably. So make sure you can load, edit, and save CompuCell simulations into Edit. Make sure you can run some of those demos. We have a list here of 3 demos that if you can run all 3 of these, that's a pretty good test that all of the various packages and everything installed correctly. So if you can run those 3 demos and nothing crashes and you get no errors, then you should be good to go. If you'd like to do any background reading, please feel free to explore some of the resources that we provided. Again, you don't need to be an expert coming into this workshop. We'll teach you everything you need to know. But having seen some of these ideas previously will make encountering them in the slightly more intense atmosphere of the workshop a little bit easier to manage. And by intense, I just mean we're going to be covering a lot of material over the course of these 2 weeks. If you are planning to participate in the hackathon, we do ask that you start thinking about a project you want to do or what kind of project you might want to join. We'll have a quick survey sent out this Friday for people to fill out their hackathon interests and kind of what they plan on doing for the hackathon or what they might be interested in helping somebody else with. So that's all I have for today. If there are any questions, I'm happy to stick around for a little while. If you do not have any questions, then you are free to go. And again, you are always welcome to send me an email later if something occurs to you after the session. So thank you everybody for your attention, and you will be hearing from me again later this week.